This is day 2 of lesson 8.1, and this is simplifying expressions by combining like terms. I mentioned like terms in day 1 video, so that's something that we want to use going forward, and you want to take good notes and write down questions, because this, again, just like the distributive property, is going to be something that you use continuing forward in math. Simplifying expressions. So a little bit of vocab here. So when a plus or minus sign separates an algebraic expression into parts, each part is called a term. The numerical factor of a term that contains a variable is called a coefficient. So notice here, negative 4x, 12, and x, they're all separated by plus signs. So these are 3 different terms. They're all different numbers separated because negative 4x and x both contain the same variable. They are like terms. So like terms contain the same variables to the same powers. So x and 2x are like terms, but x squared isn't because that's to a different power. So again, 3x squared and negative 7x squared are like terms. 8x squared, 8xy squared, and 12xy squared are, but 10x squared z and 22xz squared are not like terms, because you notice x is to the second power here, but only to the first power there. Z is to the first power here, but it's to the second power here. So those aren't alike because they're not the same variable to the same power. A term without a variable is called a constant. So for example, 12 is a constant here. And negative 4 would be called a coefficient. It's the number in front of the variable. So see if you can try on your own maybe to match which ones are alike and which ones are not. So I'm going to use different shapes to match them or write them below. So if I start with 4, what terms are like 4? Well, 4 doesn't have a variable attached to it, and neither does 17. So those would be like terms. I could combine those. Let's see. X it's kind of just like 1x. So what else has the same variable to the same power? 3x does. So those are alike. Done with those. 4g and 10g are alike because they have g to the first power. And then 7xy squared is a like term with 5xy squared. They have the same variables to the same powers. Notice then AB and AB squared are our last ones. They are not alike because B is squared here, but it's not there. So those are not alike. So we're going to identify parts of an expression. We're to identify the terms, like terms and coefficients, and constants in the expression. So in here, and you can kind of rewrite it if you need to, so 6n minus 7n minus 4 plus n, which is really like a 1n. So the different terms, if I just start with terms, because it's identifying parts, I break them out. So some people like to change this to addition first. So you might do this by adding the opposite so that you can see that they're all separated. So the different terms are 6n, negative 7n, negative 4, and n. The like terms, the ones that are alike, are 6n, negative 7n, and n, because they all have the same variable to the same power. Coefficients, the numbers in front of the variables, are 6, negative 7, and since this is really like a 1n, 1 is also in front of n. Then lastly, the constant, so the number without a variable, is -4. That's the only one without a variable. So that's how you identify the parts. So you could pause and give these ones a try if you think you're ready. The first part is just to rewrite it so that you can see how it's broken up if you change them all to addition. So the terms are each one because they're separated by an addition or subtraction. So it's 9y, -4, -11y, and 7. Each one of those is its own term. The like terms, 9y and -11y are alike. -4 and 7 are alike because they don't share a variable. Coefficients, the numbers in front of the variables are 9 and -11, and the constants are -4 and 7. So again up here, rewrite it. It's changing, all I did was change all the subtraction to adding the opposite. So then your terms are, as you see them, 3x, 2, -10, and -3x. Your like terms would be 3x and -3x, and then 2 and -10. Coefficients, numbers in front of the variables, 3 and -3. Constants, numbers without variables, 2 and -10. So now, on to the good stuff. I love this. An algebraic expression, again, is simplified or in simplest form when it has no like terms and no parentheses. So we use the distributive property before to simplify an expression. Now sometimes we're going to have like terms that we need to combine after that. So this process is simplifying the expression. So we decide that we have 4y plus y. And since they are like terms, this is also the same as 4y plus 1y. So since they are alike, it's really like I'm adding 4 plus 1, which is 5y. So you can picture this 4y is really like y plus y plus y plus y. And we know multiplication is for repeated addition, and this is plus another y. That all together are 5 y's. So in this one, you might want to rewrite it if you have a hard time with the signs. So this is the same as, if you add the opposite on all of these. So then -2 plus -7x plus 6. So what I like to do is circle and box my like terms. So I say, okay, I have 7x, and that can combine with -7x. So I could rewrite that as 7x. Rewrite it, since addition I can reverse the order. And then I have -2 and 6. So if I combine these, this is really like 7 plus -7 all times x. It's kind of giving the visual of what that looks like, which is just 0x. -2 plus 6 is 4. So I don't need this part, so this is really just simplified to 4. So this whole thing simplifies to 4 because your like terms combine. Give these ones a try. You might be able to see them a little bit. So I rewrite it. 4z minus z is actually 4z minus 1z. To visualize what this is, again, you could do this, write out the z's and subtract 1, or realize that z was distributed. So this is really 4z plus a -1z. take the z out, it's really 4 plus negative 1, and you get 3z. So 6, rewrite this with some addition. So look at where your like terms are. So it's 6 plus, kind of like a negative 3 plus 3 times n, which gives you 6 plus 0n, which leaves you with just 6 plus 0, which is really just 6. All right, so I'm going to show you another method of circling them because I like this a little bit better. So you can still add the opposite if you want to. So you can try it one of two ways. A lot of you are going to need to start with this, and as you get more comfortable, you can move on. Some of you are going to do that. For me, sometimes I just go like this and circle, taking the sign in front so that I see that is a 2 plus negative 8g, just like you would if you did it the other way. If you did it this way, 2g, and you rewrote it. And then I would also do the same thing. That's a negative 3, positive 11. So again, I end up at the same place here. So that is a negative 6g. That's what I get there. And here is an 8. So then I'm simplified at that spot. Word problems. At a concert, you buy some souvenir t-shirts for $12 each and the same number of CDs for $7.50 each. Write an expression in simplest form that represents the total amount spent. So different parts that apply. So it was $12 for a t-shirt and $7.50 for CDs. So since it was the same amount, we can let X represent the number we bought. So it's 12 times X plus 750 times X. So together, that's 12 plus 750, which is 1950X. So an expression to represent the total we spent is $19.50 times X, the number of items sold or bought, and that will give us our total. So last one. You have saved some money. Your friend has saved $50 less than you. Write an expression in simplest form that represents the total amount of money you and your friend have saved. So I've saved some money. I don't know how much that is. X. Your friend saved $50 less than me. So my amount minus 50 less than I did. So that's a minus. So if we write an expression in simplest form that represents the total amount of money we have together. So again, X is your savings. X minus 50 is your friend. So the total would be my money plus my money minus 50, which represents theirs. So my like terms are X, and that's really like 1X plus 1X, which is 2X minus 50. So I love this stuff. I love variables in place of numbers. I think it's a great puzzle. It's like you have all the information you need, and then you just kind of work backwards and replace things that you don't know with a variable, and then you can combine things. So write down questions, bring them to class. We'd love to make sure that you understand this the best that you can right away because it will continue throughout your math.